Hello everyone. Today I have a rational integral question and I'll be walking us through how to solve it. This particular question requires us to find the integral of 1 divided by x squared plus 2x plus 10. So to start, I'll just rewrite it by bringing the x outside of the whole expression. So I'll have 1 divided by x squared plus 2x plus 10. So you see the x is out. So in this form, it is clear that the numerator, which is on top, is a constant, which is 1, and the denominator, which is under, is a polynomial of order 2. The highest power of the polynomial is 2. Hence, it is a quadratic expression. Now, the question is, how do you solve an integration or integral problem where the expression is in this form? The default approach is to use partial fraction. And to use partial fraction, you have to check if the denominator can be broken into factors. So are there factors? Are there factors for x squared plus 2x plus 10? How do you check for factors? Or should I, before that, let me just explain what I mean. We need to find or break x squared plus 2x plus 10 into this form: x plus some number multiplied by x plus another number. So the question is this possible? Is it possible to break this whole quadratic expression into this form? Easiest way to check for that, if that is possible, in this case where the coefficient of x squared is 1, the easiest way is just to check for factors of 10 that will add up to 2. So for example, a pair factors of 10 is 5 and 2. When you multiply 5 and 2, it gives you 10. When you add 5 and 2, it gives you 7. You need two factors that will give you 10 when multiplied, but then when added gives you the middle term or the coefficient of x. So are there such factors? The simple answer to that question is no. So we can conclude that no factors. So partial fraction method will not work for this question. The second, so if partial fraction doesn't work for this, what is the next default? The next default is to use completing the square. So let's use completing the square. I'm just going to write it here: completing the square. Completing the square is just a method we use to express any given expression in terms of the perfect square next to it or closest to it. I'm going to explain it with a constant. Okay, completing the square, right? So we have x squared plus 2x plus 10. We would write it relative to the perfect square next to it. But let me explain with a constant. So let's say you have 5 and you want to write 5 in terms of the perfect square next to it or closest to it. So the perfect square closest to 5 is 4. So we can essentially write 5 as 4 plus 1, which is essentially 2 squared plus 1. Another example, if you have 13, what is the factor? It depends on what you're trying to achieve. What is the perfect square closest to 13? You have 2. You can 2 of such. 9 is 1, so you can have 9, which is an interesting choice actually, because if you choose 9, you can say 9 and 4, which is actually the sum of 2 perfect square, right? So you can have 3 squared plus what? 2 squared. You can decide to find 13 in terms of the closest perfect square greater than 13, which will give you 16, right? So you have 16 minus 3, which will end up giving you 4 squared minus 3. I mean, that's just what completing the square is. I mean, it's a little bit more involved because they are expressions. They are not just it's an expression. It's not just a constant number. So I'm just going to use the same approach to find the find this perfect this quadratic expression in terms of the perfect square nearest to it. So it is, if you're very familiar with quadratic expression or equations, you will know that x squared plus 2x plus 1 is the perfect square that is closest to this expression. So I can simply write x squared plus 2x plus 10 as x squared plus 2x plus 1 by simply adding 9, because 1 plus 9 is 10. At the end of the day, I will have x squared, sorry, give me a second, that's a mistake. I will have x plus 1 all squared. This whole portion, let me do it in this whole portion up here, x squared plus 2x plus 1 is the same thing as x squared plus 1 squared, because when you expand x squared, x plus 1 multiplied by another x plus 1 is going to give you x squared plus 2x plus 1, and then you have plus 3 squared. So now I can come down here and say my integral x squared plus 2x plus 10 dx is the same thing as integral 1 divided by x plus 1 squared plus 3 squared dx. Now this is more relatable, and it reminds us, if you to an extent familiar with integrals, you will recognize this as very close to an identity. I'm gonna write the identity here. So now in this form we can use an identity. There's an identity that says if you have integral 1 divided by x squared plus a squared dx, when you have an integral like this, this is the same thing as 1 divided by a tan inverse or arctan tan inverse of x divided by a plus c. So in this case, this whole term will be the x. Actually, I could have used another so give me 1 second. I could have used another variable here, so it is not confusing. So I can say let me change this to, I can use another variable. I'm just thinking of which variable to use. Let me just use f, which is not a good choice, but so yeah, when you have 1 divided by f squared plus a squared, a being a constant, f being a variable, df, then you can use this. Now I know this in this case, this is a special case, is a simplified case. In this case, x plus 1 is the f. By comparison, f will be x plus 1 and a will be my 3. So simply put, I can just go straight to the integration and say integral x squared plus 2x plus 10 dx is gonna give you 1 divided by a, which is 1 divided by 3, right? 1 divided by 3 arctan, which is tan inverse. It's not 1 divided by tan, it's arctan. F being x plus 1 divided by a3 plus c. So this gives you the integral of the rational expression that we're given. Now, there were some other explanation I should have added here, and I'll just quickly add a tip. The reason why this worked, even though it was not just a variable, because this itself in itself is a function, the only reason why it worked is because when we take the derivative of this, we get 1. If we got something else, then we would not use it straight up. We would do some use substitution. But for the sake of this question, this is good enough. So that's how you solve this. I'll make more videos about contents like these, and I'll go through the basics, explaining how you do partial fraction, factors, completing the square, the actual steps or methods for completing the square. I'll go through a lot of other things. I don't want this video to be too long, so I will stop here. Thanks guys for watching. Watch out for my next video. If you like contents like these, please subscribe. Thank you so much.